Alright guys, today is August 27th and we are going over equations of parallel and perpendicular lines. Okay, so this is an important concept that you actually already got in Algebra 1. I'm going to use it to review some of these important Algebra 1 concepts that you're going to see again in Algebra 2, so we really want to make sure your foundation is strong. The first one is slope, right? So of course for slope we use the letter M because that made sense to someone. And we know that slope is, by definition, this kind of delta y over delta x. And we've already seen that delta notation means change in. So how is the y changing with respect to the change in x? All right, that's probably my favorite definition. One you're probably familiar with is rise over run, which is very useful on a graph. And then, of course, we do y2 minus y1 over x2 minus x1 if we're given points, right? Now it's just important you're consistent. Whichever point you label point 2, if you start with that y value up top, you have to start with the corresponding x value on the bottom, okay? So that's slope. What a lot of students tell me when I ask them what slope is they tell me y equals mx plus b. All right, this is not slope. This is called slope-intercept form. And as I'm sure your math teacher told you, we are not clever in the Math Society. And it's called slope-intercept form because this is the slope and this is the y-intercept. Okay? So again, this is just a review of some things that you should know. Now, I'm not going to go too in-depth with this, but what we should recognize here is that two lines are parallel if and only if they have equal slopes. Sorry, I don't know what happened here. That's supposed to be a Q. So if and only if they have equal slopes, okay? Or are both vertical. Because technically their slope is infinite or undefined, all right? So two lines are parallel. When we hear parallel, we should think same slope. When we hear parallel, we should think same slope. Okay? Now here's the different one, right? Two lines are perpendicular if and only if, and this is different probably than what you learned in Algebra 1. You probably learned about what's called the negative reciprocal. But I'm going to tell you here, the product of their slopes is -1. Okay? Now this makes sense, right? So here, when we think of this perpendicular, we want to think of the negative reciprocal. Okay? When we see perpendicular, we should think negative reciprocal. And this makes sense, right? Because imagine we have a slope that is something like a over b. Well, what's the perpendicular slope going to be? Well, I'm going to flip it and change the sign. So it's going to be negative b over a. That would be the perpendicular slope. Now, product implies multiplication. So if I multiply these, what happens here? Well, I get negative ab over ab. And we know that anything over itself is just 1, so I get -1. So this is just a more concise way of saying that. So the product of their slopes equals -1. Okay? So again, parallel and perpendicular. Now there's a few things you're going to have to do this chapter. Looking at graphs and determining slope using rise over run. Being able to calculate slope by reading the points off the graph and using slope formula. But the big ticket item, the big one we want to be able to do is problems like this, right? Which are going to say something like, find the equation of line perpendicular to line L and through point P. All right, so that's what the directions will say. So this one's perpendicular, but just as easily it could be parallel. So I'll go ahead and do that with both of them. Okay. And what we're going to do is we're going to go ahead and say here that line L has the equation y equals 1/2 x minus 3. And that point P has the ordered pair 4, 1. Okay, so this is the setup of the problem. Okay, so first I'm going to go ahead and I'm going to do the perpendicular, and I'll do that in purple. Okay, so the first thing we're going to do is we're going to steal this slope. Okay, so by looking at this equation, I can see that the slope is equal to 1/2. So if the slope is equal to 1/2, what would the perpendicular slope be? Okay. If you're not sure, you can actually set up an equation, right? And you can do the one slope times the perpendicular slope. I know it has to equal -1. Well, we multiply by 2 to get rid of the 1/2. Whatever we do to one side, we do to the other. And we find that the perpendicular slope is equal to -2. Now what I have here is I have the slope, and I have a point that it goes through. So consider our equation. Y equals mx plus b. If I want to write this equation, I have to know m and I have to know b. I don't know b, but I know y, m, and x. So I'm going to plug them in. My y value I'm going to steal from this point right here, right? Because this ordered pair is always x, y, right? So here I'll put 1 in for y. I'll put -2 in for m. And I'll put 4 in for x plus b. So if 1 is equal to -8 plus a number, that number had better be 9. So now I can write my equation, which will just be y equals -2x plus 9. So you can see here I use the perpendicular slope and the b value that I found. Okay? Now here, if we were to do the same problem, but we're looking for parallel, right, what would the parallel slope be? Well, the parallel slope is just equal to whatever the original slope was. So if the original slope is 1/2, the parallel slope is going to be 1/2. And then we still have the same ordered pair, right? 4, 1, where this is x and this is y. So I'm going to do the same thing. Y equals mx plus b. I'm going to plug in for y, m, and x so I can solve for b. So we can see here y will be 1, m will be 1/2, x will be 4, and b is what I'm solving for. Half of 4 is 2, so 1 equals 2 plus b. b had better equal -1. So this equation will be y equals 1/2 x minus 1. So if we take a look here, we've done 2 problems in one, just to show you here, right? So if the problem asks for perpendicular, I'm going to do what's in purple here. I'm going to find the perpendicular slope. And you can use the negative reciprocal trick, that's fine with me. If instead they asked me to find the parallel one, I would do what's in pink here, and I would just use the same slope. But in general, you're going to steal the slope from this equation, all right? So I know that this equation right here represents a line that is perpendicular to L and through point P. And this pink equation represents a line that is parallel to L and through point P, all right? If you have any questions, please email me, but hopefully this helps with today's concept.